Okay, this is Programming 101, the first lecture to actually teach you how to program. All right, hopefully you have Hello World open from the previous exercise. If you haven't done Hello World yet, go back, create Hello World, get yourself here. You can leave whatever system out statements you have in here, that's fine. It works just fine. We've created our first object. If I go over to the left-hand side over here and I click on it, I see I have two little items over here. I see this little file, this .java file. Some people have gone up here and clicked it in the package area. This is the identical view. It's the Project Explorer viewing your file system and making an abstraction of your file system. I don't care where you click or what you do. I have a tendency to close this project thing and work with it this way. I also have a tendency to close it completely and just work with it here. As you open this up, there's different sections of the program because this is a very small program. It doesn't do anything. If I clicked here, it would take me to this part of it. Now this part of it is this part of it. So as we add stuff to like methods and things to this, we're going to end up with a situation in which we're going to have more populated stuff over here. So don't worry if your stuff shows over here and my screen always looks like this, is what I'm saying. It's just note to self or note to audience. I like to simplify things, and I don't use the Package Explorer for what it's worth. So, all right, all classes, and don't do this. Don't do this. I'm going to do this. I want you to leave this one alone because you have a working Hello World program. If you want to do this, you have to make sure we delete what we're going to do. You can do this actually if you want to. Otherwise, you can leave your screen open and you can use hello. But I want to show you something. I'm going to close this window and I'm going to save it. If I want to open it back up again, I just double click on it. It opens back up. This is a tab that's up here on the top. I'm going to close the tab. You can do this if you want. Close your tab. Leave hello alone. Maybe not a bad idea if you want to do this actually. If you want to follow along, you can do this. You can click on source or you can click on default package or anywhere you want actually in the project. Come up to file, new. We're going to create another class. I'm going to put another class in here. I'm going to select class. I'm going to leave it on public right now. Same thing as we did before. But I want to show you what this is about. So the superclass is object. This is object orientation 101. Everything's an object. Table's an object, cup's an object. Everything you do in Java is an object. You're constantly creating a class and then another class and then another class. The class is the programming term for the implementation of an object. They call it the same thing in C++. In C++, you have a public class, or you have class, my class, and then you have different syntax. We're going to look today, right now, at the syntax that we're looking at for Java. The syntax varies slightly for C++, but you can actually learn that language simultaneously. It's practically the same syntax, very similar. Runs differently though, so just keep that in mind. Class objects always have a capital letter, so I'm going to do this one. I'm going to call this one test with a capital T. If you're doing this, do a test or something. We're just going to create a class object. Now I'm going to leave out down here. I've unselected this over here. I want to leave this out to demonstrate a point that the object still works. It's just not a main object. It's not a driver object. So this is test class. If I press finish, I get the simplest of all. This is the base class. I don't get anything in here now. I have public class test. And in public class test, I have an opening and a closing bracket. Believe it or not, that's a self-contained object. That's the template to create an object or to create a class. And then we stick stuff in the class. In Hello World, we had a main menu that was our driver, that was our main method that we used to print some stuff out to the screen. This one, it doesn't do anything. But I can include this, and I can make instances of this in other programs if I want to. Or I can actually add main to this one, which is another thing we can do. So in programming, we have a couple little things we can do. First thing we're going to need to do is keep track, and what I'm doing is Programming 101 right now. So I've opened up this fresh one. If you don't want to open up a fresh one, you don't have to. You can use the original one. You can go back to hello. If you're in the hello file, make sure you type everything in between the opening and the closing brackets of this method main. But let's go back over here. Variables. Variables hold data for us. We have about 3 different things in the programming. We have variables, and then we have flow control. And then we have objects and object orientation methodology. So variable is going to hold data. The simplest data type are called primitives. So primitives in the language are built in. When we create objects, we create our own user-defined data types. They're sometimes called complex data types. So primitive, as a primitive, could be int, could be double, it could be float. Those are some primitive ones. If I type these words in, I get this little thing here, because I'm typing in data types. It's going to tell me that I've incomplete, and I'm going to have, because I'm just thinking out loud and typing at the same time. The syntax for a variable, and now I'm going to show you another thing that you might find helpful. And what I'm going to do at the end of this lecture, by the way, is post this on the Canvas website and in the YouTube video, so you have the finished product of whatever it is we create. So you don't have to worry about typing this and capturing this if you want. If I want to put a comment in the code, I put 2 backslashes or forward slashes that look like this. I'm going to say data type, and then we have a name. And I'm going to use this syntax. This is what you get in textbooks all the time, actually. This is how you create a variable. And this is a variable equals a data type plus a name. So you've written your first comment now, actually. So if this is a data type, and data types, primitives are int, float, double, there's some more, character, there's some more. I'm not going to bore you with like every single data type that's out there right now. Make this a little, I'm going to use the real estate I have. There we go. So if I want to make a proper data type, I can use 1 character for the name, and every single line of code ends with a semicolon. That you got to memorize. You're going to need that one. Or I can make a data type that has a bigger name, like my int. I'll leave that alone for a second. It's still problematic with these guys. Here we go. So you notice as I have been typing, my red stuff has gone away. If you see red stuff, actually, let me put some red stuff in here. I'm going to make another int. I'm going to call it a test. See how this is, if I push my mouse over the red stuff, it'll say syntax error, insert a semicolon to complete the field declaration. So it will try to help you. If this doesn't work, you can always put your mouse over here, over this red button over here, and it says the same thing. In Java, they call these fields. In C++, they call them data members. In C, they call them variables. It all means the same thing. They're going to hold data. What I just did here, if I correct this line of code, is I've created 3 variables, and I did them manually. Variable names cannot have spaces in them. So this isn't going to work. That's going to give you an error. This is the long way of doing this. Is called a variable declaration. So these are variable declarations. I'm giving you the syntax right now. And then if we have another thing called a variable initialization. I've probably misspelled that word, but let's see. And don't take my spelling as correct for the most part. If I said that I is equal to 5, and that my int is equal to 10, and that test is equal to 20, I've initialized these variables to include, what's wrong with test? Oh, because of the test. I'm going to call it my test. There we go. So to declare a variable creates the location for it in memory, identifies it, and says that this is going to be a variable. To initialize it, adds a value to it. This is done in 2 separate steps, and I did this the long way. I'm going to show you a shorter way of doing this. And I don't know why my thing is red, but let's just see real quick here. I'm going to save it. It says as expected, syntax error on token. Expected after this token. I don't know. Got issues. Let's just forget about those errors right now. Actually, what I can do is this. This is why I like the multiple windows, actually. I'm going to do this. Copy. I'm inside of a method here, which is going to have slightly different behavior to it. There we go. You notice in this method, because the syntax, what I just did a few minutes ago is I copied. In fact, you could do this yourself if you want to, if you did the same thing I just did. I'm going to make my life easier. I'm going to stick it back in Hello World. I stuck it over here because I wanted to show you that you don't need a method to do this. But unfortunately, the syntax isn't going to really do anything. So, and I'm going to show you another thing real quick here as well. I decided that I didn't like to work with test.java. So I copied it. And I pasted it over here. And now over here, because this is in the right syntax, I'm getting yellow now, which I didn't see before. The yellow is telling me that the value is never used. A yellow is a warning. A red is a message, an error message. So the warning here, because this is in the right context, the warning is that, hey, you created these variables, but you haven't used them yet. Okay. So if that's the case, then maybe I should use them. And we're going to use them in a few minutes. But I put them back into main because I already have my system out, and I'm going to modify my system out statements to use these in a few minutes. But we're going to see what we're going to do with this. Meanwhile, I'm going to save this one. You don't have to save everything all the time either. And I'm going to show you how to remove something you don't like. So let's say, for example, I decided I don't like test anymore. I'm not going to use test. I can remove test out of the project. I can do that by right mouse clicking on it and selecting delete. And then it's going to be a little prompt that comes up. If I do that on test.java, I should see test.java in here. If I say OK, it takes it out of my project and removes it, and it's going to take it out of the workspace folder. Don't do this, but let's say you don't like your project. You can actually right mouse click on your project and click delete. Some of you have actually done this already. Don't do this right now. If you want it to come out of Eclipse but stay in your workspace folder because later you're going to want to use it, don't do this. Do not do this. Don't do this. Don't do this. I'm going to delete this from my Eclipse and I'm going to put it back in, but don't do this. I seriously do not want to go around fixing everybody's computer right now. Okay. I'm going to press OK. I'm deleting the project, but I'm not deleting it from the project folder. It's still on my disk. So I'm going to press OK, and I'm going to go, oh no, contains resources are not synced. Okay, that's okay. Continue. It's gone. That's why I say don't do this. If you want to put it back, if this happens to you, you do this. You go File, Import. You can export it as well. I'm going to import it now. And I'm going to import it. I'm going to come back in here and I'm going to say existing projects into the workspace. Let me show you something. Actually, I'm going to close Eclipse for a sec. Don't do this either. I'm going to go to the workspace folder. Documents. I probably have to retype those variables as well because I don't think I saved it. Sunday school. Oh, hold on one second. Here's Sunday school. Let's say I downloaded Sunday School from the internet. Nothing is in my workspace folder right now. I just dragged it out. Let's say I downloaded this from the internet and or from the Canvas class, and I want to put this into Eclipse. First thing you're going to wonder is how in the world do I get into Eclipse? So I'm going to click on Eclipse. I'm going to go, okay, I'm ready to go. I'm going to do this. All right. Oh, I'm going to select my workspace folder. Great. And it comes up as empty. You have to import it in to actually bring it into Eclipse. You can't open it. If you double click on this file, you just see you just see those folders, source and bin, and bin's not going to work for you. Actually, you could probably double click and run bin, depending upon how you got your program set. So that's the executable file. And you're going to get this one. If you double click on this one, you're going to it's going to end up showing up somewhere in your text editor somewhere. That's not going to work for you. Instead, you're going to go to the Eclipse program, and you're going to come into File, and you're going to import. And I'm going to import an existing project into the workspace, which is right up here under General. And I'm going to click on Next. And then I'm going to select my desktop, because my desktop is where I just copied that thing. And in my desktop, I see Sunday School. And then I'm going to press Open. And then I'm going to see this little Sunday School program show up in my little window here. And then I'm going to press OK. And it's going to say copy the projects into the workspace. If you don't copy the projects into the workspace and you open it up and you import it in from the desktop, it stays on the desktop. I would just put it into the workspace folder, because then what you're going to end up doing is accidentally deleting it from the desktop. So if I don't click this one here, it's going to run it from the desktop where I have it right now. If I want to copy it into the workspace folder, it's a better location for it. I highly recommend that. And by default, it's actually selected for you. So if I do this and I click on Finish, it's back into my Eclipse folder. It might actually not be my current version, because I believe I have changed it since then. My variables might be wrong. Oh no, my variables are there. That's good. Okay, good. But lo and behold, if I go back to my workspace folder now, you're going to see it. I'm going to see it out here. I could throw this one away. Don't need this one anymore, because I copied it into the documents, into the workspace folder. There it is. It's back. That's how I got it back. It's going to take you a couple tries. As soon as you accidentally delete something and you have to put it back, it's going to take you a couple tries to figure that out. Just keep that in mind. That's how you're going to get something back out. So let's continue talking about variables. I just took that small tangent just to kind of show you something. These are all done separately. I have an integer I have my integer. If I want, I can string them all together. So as an example, I can do this. I can go, I'm just working with ints right now. Integer is a single value. It's a number, whole value, whole counting number. Integer counting numbers, like 1, 2, 3, 4, 5. If I want to go like 1.5, then I got to go into a double. That's going to give me a 2-place decimal, or a float that's going to give me like 6 places if I want. So floats and doubles and integers and characters and strings are probably what you're going to work with. And I'll look at those in a few minutes. But if I can do this in one shot if I want to. You can only use the same variable name one time. You cannot reduplicate variable names, nor can you reduplicate method names or anything else. So I'm going to say A, B, C, D, and E. I've now initialized 1, 2, 3, 4, 5 variables all in one shot. This could be like, I can make them longer names, an int, a B int, a C int, a D int, and an E int. So I got multiple variables going on there. This does the same. Does the same as above, but all in one line. Okay. Now I can also do the same thing with the initialization. I can say that A int is going to be equal to 1, and that's B, and then here's the other thing that you're going to go, we're just going to type this all in one line. B int is equal to 2. And I'm putting a semicolon in between. I'm trying to put a semicolon in between. To demonstrate a point that this entire program can probably be written on one line if you wanted to, as long as you put a semicolon at the end of the lines. This is not so good though, harder to read. Instead, the user would actually do this. Integer A is equal, integer A int is going to be equal to 1. B int could be equal to 2. And here I have spaces, and here I don't have spaces, and who cares? The spaces are just white spaces. This one's going to be equal to 3. The This one's going to be equal to 4. And this one's going to be equal to 5. So now I've done this one, but this is going to overwrite this one. Every time I assign a value to it, that's the value I'm going to get. So, okay, so I'm going to get rid of this line because I don't want it. But this is what's called a variable declaration and initialization all in one shot. And I've strung them all together. More common to see this, because this is tedious. You know, all these separate variable declarations and then you have separate initializations, very tedious. This one here is a little bit more effective. So you're like, okay, now great, this is cool that you have all these integers. Do something with the integers. So integers, what can you do with an integers? You have available operations, addition, subtraction, multiplication, division. So I'm going to actually take this out of here because we don't need this. And I'm going to play around with it. I'm going to say, e int, because once I've initialized it, now I just use the variable. And I'm going to say this one's going to be equal to a int plus b int. So now I have e int, here's e int, that was 5. If I print this to the screen, and let me just pull this guy out here. I'm going to change my output a little bit here. Let's see, paste. I could put e int in here. If I put e int in here, now all of a sudden you see all this new coloring that's going on now. Now when I press my mouse over here and I want to highlight something in the code, I highlight this one, I see this one here and this one here. So it's telling me where it is in my source. So I can combine this with another statement and say something like, let's do it this way. Edit, cut, edit, paste. Excuse me? It'll be 2, excuse me, it'll be 1 plus 2. It's going to equal to 3. We're going to see the output in a second here because I'm going to do this way. So e int equals, and then I'm actually just going to do print on here because I want there to be one line. Actually, this line here is good, print line at the end. I'm going to take this away. You don't have to do this, but if you are doing this, I'm probably typing too fast for you. We'll see. So I'm going to leave this on the board. I leave this up here so you can kind of sort of see it, and you can continue typing it and running it. When we set e int to 5 up here, and then I reset e int to a plus b, a int plus b int, so now I got e int is equal to 3. And now you're going to see the power of the system out. I didn't have to put quotes around it because I wasn't systeming out anything but text here. If I want to put text in here, I have to put quotes around it, and it turns blue, which is why I like Eclipse. It sort of color codes everything for me. And in here, I just put the name of the variable, and it printed it out for me. So I can now print out any of the other variables I want using the same technique. And then here I used the print instead of the print line because I didn't want there to be a line return between the first statement and the second statement. So now I have a pretty sophisticated kind of thing going on here with my integers. Now I'm going to branch out a little bit here, and I'm going to use a character and show you what that looks like. So I can say character, my character, equals, and if I'm going to use a character, I'm going to put a single quote in here and just say a. So now I have another variable called my character. The data type for the character is character. Character is a single character. So when I assigned my character equals a, I've assigned it a single character. This is equivalent to doing this in 2 steps. I could have said this as well. I could have done character, my character, and then I could have done my character is equal to a. Now that's the same thing. And I'm going to comment this out because it's going to be a mistake because I already have my character down here and I can't use it twice. So I'm going to comment that out. But that's the equivalent in terms of the code. Now if I want to print that out, then I can say system.out.println And then I can put this together if I want to with concatenation. I can do this. I can go, my character, well, that one equals, and then I can put this like plus in here and go my character. And then put a semicolon at the end. Now I've used the plus for concatenation instead of addition and subtraction because my character is a character. So if I were to run this, I see my character is equal to A. Well, I'm going to have to put a little space in here if I really want to make it look good. There we go. Because, you know, the A was right next to the equal sign, so I put another little space in there. Actually, I could put a space in here if I wanted to. I guess that would have been the easier part. But then I wouldn't have been able to show you that you can concatenate anything you want together. I can actually even concatenate, if I want to, the value of another variable. For example, I can say here, I can say plus, what do we got up there? It's E plus E int is equal to plus E int. So now if I run it, it's going to say my character is going to be equal to my character. And then I'm going to put a little space here because that's going to be like butt up against each other. And E int is equal to E int. So if I run it, it looks like this. My character is equal to A and E int is equal to 3. And like E int is equal to 3, yeah, it's the same E int up here. So the values are being stored in the variables, and I'm printing the variables out. And I'm concatenating them together in my output using a plus symbol. And it's the same plus symbol I used up here, but this plus symbol in this context is taking two integers and adding them together. So when you use a data type, the operators that are available for the data type are automatically translated into what they do. So as an example, I can take a string. So let's go down here. I'm going to make another line of code here. This one's going to be called string, and it's going to be first name equals Barbara. And then I'm going to have a string, last name equals Hecker. Heckler. There we go. What is my name? And then I'm going to write another system out call. Actually, I'm going to do this one. I'm going to go string combined is equal to first name plus, put a little space in here because I don't want them to be like back to back, you know. And I'm going to go plus last name, and then I'm going to print that out. It's a string. I can just put it in there anyway. So I'm going to go system out, and when you're typing in string, remember what I told you, and you'll never forget this. Everything's capitalized. Except for primitives. All objects are capitalized. Primitives are not. That's why over here int was lowercase. It matters, it's case sensitive. If you're having typos, make sure anything primitive built into the language is in lowercase. And anything that could be, like the notion of an object, anything could be an object. If the small doesn't work, capitalize it. I believe the string actually works uncapitalized, but it's a good practice to capitalize the S in the string, because then you're going to get a string object from Java. And if you press on the string data type itself, it pops up this little window, and it says that the string class represents character strings. Class is an object. If it's a class, if it's an object, it's capitalized. The first character is capitalized. You can't capitalize the whole word, that doesn't work. So Java, just like C++, just like C, is very case sensitive. Yeah? A character is a single character. You can't put like doubles in here. That's going to come up. See, it says, oh, looking for a single character, invalid character constant. If you put one of them in there, you're in good shape. Multiple strung together is now called a string. So if I system this out, system.out, yeah? In here, if I don't do this, it's going to be butt to butt. Actually, here, I'll take it out and you'll see what's going to happen. because I'm gonna print it out in a few minutes here. I'm gonna print out my name is, and I'm gonna put here combined. So it's gonna be Barbara Hecker with no space in between. So if I run it here, it says my name is Barbara Hecker, but I want a space there. I could do that by putting a space here. That would actually fix the problem. Or I could leave this one alone and then put a space here by going first. Actually, I could put it in here. No, I can't. Combine is there, so I can go like this. Put the space in here. You can string anything you want together with concatenation. Which plus? That's going to be a problem. It's not going to know what to do with it. I can do this if I want. I can say that the combine is just the first name. That's a variable assignment, a string to a string. Works just fine. You can't do this. You can't say last name. It's going to be like, what do you mean? Last name. You actually have to use a concatenation to put it together. And then it goes, oh, okay, I understand what you mean now. So that's concatenating two values of a string together. I can actually do this if I wanted to. I could put the C in here. I can come back and say my character. Characters and strings are compatible back and forth. Yes? Single quote for combined? Like here? Oh. Up here? If you put a single quote in, you're going to have the opposite problem that you had with the character. Single quote is going to be a single character. Double quote means more than one. So if you put your mouse over here, you're going to see it's going to say too many, or it's going to say invalid character constant. So when you're using a string, it's double quotes. Just think, if you want to remember it this way, character is one. So you have one single. A string is more than one. So if it's more than one, you're going to put double. And always remember, this goes, this is really bad English, I guess, for this programming. Because they always say put the dot and then close your quotes. No. It's not English class, unfortunately. You have to break the syntax rules of proper English. In that particular case, I don't know, some people I've seen tried to put like a dot there, like at the end of the sentence. Those are not sentences, and we're not writing English statements, we're writing programming code. And so the semicolons always go at the end. If you leave the semicolon out, then you're going to hover your mouse over and it's going to say, syntax error, inserted the semicolon to complete the variable. Okay, so you do this. There's some people that will end up like leaving one out, like up here, and then you get an error message down here. Problem is you got to go all the way back up to the top. And the problem with programming for beginners is that you have to fix your own code. And that's really the battle, is trying to get your code to work right. So we have my name now is combined. So let's throw some doubles in here too, and some floats. So if I'm going to throw a double in here, well, let me show you what happens when I use an integer like a double. We have integer, I'm going to play around with A. I'm going to play around with D, because otherwise I'm going to mess up my value of E. So I'm going to put some code in here. I'm going to say that D int is going to be equal to 12.5. And then I'm going to hover my mouse over here, and it's going to say that type mismatch can't convert from double to int. And then I have my first kind of clue here in terms of what's wrong. And then I have this lovely little help system where if I press this add a cast to int, it now takes this double value and it casts it to an int value. Let's see what this value actually is. It's going to be cut off. Yeah, it's going to be chopped off. It's not going to be 12. So, system out. And the way you're going to learn the syntax is just to keep typing it. If I can type it, system.out.println. my double as an int is less d int. My double as an int is that d int is going to be 12 because I casted it, and I'm going to show you the cast in a few seconds. It's 12. And you're like, isn't it 12.5? Shouldn't it be 13? No, it doesn't round up or anything like that. This is what they call a cast. This is a data type cast. The help system had me do that because I was declared an integer d-int and I assigned a float value to it. So let me go back and fix the problem a different way. Because I turned a float into an integer by casting it to an integer. And the cast works like this. You have an opening int and a closing bracket. And it's almost like you're redeclaring it. A variable declaration here, if I actually wanted to create a double, I would use the word double, not int. And I would say double D is, I could just do like this, double D. Double D works just fine this way. I can say D, and then I can take this out. And I don't have to cast it now, because double D is equal to 12.5. And if I printed out D here, this is my double. It should print out 12.5, which it does. My double is 12.5 down here. And you might be noticing something that I'm doing. Because my window is small, I'm going to go, hey, that's not my output. My output doesn't look right. I'll just scroll up a little bit. Have it scroll down. so now I have a double. If I wanted to, I could take this double value D and cast it back. I can say my d-int is equal to an integer D. Now I just took my integer d-int, took the D and casted it to an integer. Or better yet, I could do the opposite and say that D is now equal to the double value of d-int. Now you're doing it the opposite way. So I'm changing one variable type to another variable type. And it's called a cast. Normally you don't want to cast unless you get into trouble. And you have to use like types together, which is why you end up casting sometimes. So for example, I have double D, and double D is equal to 12.5. Well, I now want to take, and I want to say that double D comma DD. And now DD, I want it to be equal to D plus dint. And then, ooh, that's an unsafe cast. Normally double. Oh, did I double? D. D is a double. This one plus, this one is still this one. That should give me an error. Why did it not give me an error? It's an unsafe cast and Java let me do it. But now my double is 4.0. That's weird. How did that work? My double. Well, let's do it this way. I'm going to take here and go a int. It works. Eclipse is letting us work by putting in a type. You're not supposed to take a double and add it to an integer. If I did this in C, it's bad practice. It's an unsafe cast because you're going to round it. And this one is taking a double and adding two integers together. Integer a int plus d int. Let's see what happens if I stick it here. My double. I'm taking two doubles and having it equal, two integers, adding them together and having it equal to a double variable. I might have to switch to strings and numbers to demonstrate what I'm trying to do. It's called a type mismatch. You're not supposed to take integers, but that's a safe cast because integers are smaller than doubles. What this means is the data is organized by its size, how much memory it takes up. And it's given an English name to represent the amount of memory. Int's the smallest. Double is made up of ints. Floats are made up of even more ints. So we have a precision that's higher with a float than it might be with a double because it's taking up, it has the room to store more precision, but the precision is inaccurate because it's a floating point issue. But that's a different story completely. But a string as an example shouldn't work unless this is concatenating. These are integers. Adding integers together and assigning it to a double is an interesting thing. Let's see if it actually works, because integer a is 1 and integer d is 4. So my double should be 4.5, or no, 5.5. 1 plus 4. Is that what this was? Did I rewrite d? No, d is 4. So it should be 5. So if I run it and I don't get an error message, I should get 5.0. So it took and turned it, it's an unsafe cast. Because what you should have done is this. You should have done this double. So the unsafe cast was leaving the explicit cast out of it. Normally you can't mix and match. It's like taking, here, let's do a double and a character together, or an integer and a character. That's definitely not safe because a character is smaller than an integer. So I'm going to say that a int is now going to be equal to my character plus d int. Now my character is an unsafe cast, so it's going to say it can't be resolved to a variable. Well, okay, wait a minute. Where's my character? Oh, because it's further down. Let's just do it this way. A different error. Character, another. Now I have a character, another. And, yes? Oh. Excuse me? Oh, okay, I'm sorry. Okay, I'm sorry. No, I asked you to do that? That's really good. Where do I need to back up somewhere? Where do I need to back up to? 2 hours before? That's not fair. That's not fair. What I'm trying to do is create a variable mismatch. You're supposed to be able to add apples and apples together and oranges, but you can't take an orange and add it to an apple. If you do, you got to cast it. If the cast is safe, Java lets it happen. If the cast is not safe, Java won't let it happen. That's what I'm trying to demonstrate. If I've lost anyone, which I think I may have actually. But we're almost close to lunch, so if you hold on for 2 seconds, I'm going to complete this thought, and then I'm going to let you relax for a little bit. If I said here character another, and we know a int is an int, and I have it equal to another plus d int. If I hover my mouse over here and I look at it, it's going to say local variable another may not have been initialized. That's a different problem. That means we created a character, but we didn't initialize it. Which means I need to give it a value. And I'm going to give it E. And I gave it the wrong value because I used double quotes. So I'm going to come back and I'm going to use single quotes on that. So now I gave it a value. Oh, I'm still not even going to get an unsafe cast. Okay. So now I have a int, which is equal to another plus a d int. Is that going to give me E, where's D int? 4? E4? And is E a number? And a int is a number. So it really wants to print a integer to the screen. So if that's the case, I'm going to put it here just so I can see what it looks like. A int. And I'm going to say my funny number is... because this is weird. This is a character, and I'm adding it to an integer, and I'm assigning it to an integer. And D, from my memory, is 4. Unless I change D here. No, D int is 4, and another is E. So let's see what this thing actually prints to a screen. 105. That's the new math. That's because that's the ASCII equivalent number of E. It's an unsafe cast, but they it worked because of the E character, ASCII character. So I'm going to try this mistake one more time. I'm going to actually do a string here. I'm going to say string. My string is equal to hello. Okay, we're good so far. Now I'm going to take out another, which is a character. I'm going to put a string in here. A string's an object. And if I hover my mouse over it, it's going to say type mismatch. Haha, that's what I wanted. I was hoping for this. This is what I wanted to do. It says type mismatch. If you ever see type mismatch error, it means you're trying to take something that's not compatible, that can't be converted. The ones that we just did were unsafe conversions. They're called unsafe conversions because we didn't explicitly convert it. It still works, but we got 105 instead of E5. We got the wrong value. It's unsafe because it's unpredictable. It's not unsafe because it's going to give you an error message. It's just because we don't know what the answer is going to be. This one you can't do an unsafe because it's literally impossible to take a string and convert it to an integer. It doesn't work because a string is an object.
So you cannot steal one.
Yeah, you can't turn it into an integer. It's a string. So it's an unsafe cast. If I did this, if string, watch this little trick though. If string was like say 1, and I casted it to an integer, it's going to tell me it's an unsafe cast as well. Or it's going to say that it cannot cast. It cannot cast a string to an integer. Because a string is an object, and you can't take an object and cast it to a built-in primitive data type. So you work with your objects with your objects. You work with your primitive data types with your primitive data types. And you can't mix and match. And if you're going to work with data types, you're going to do apples and apples. If you do apples and oranges, you're doing casting. If you're going to do casting, you're going to make sure it's safe. Otherwise, you're going to get some really weird stuff that comes out of that. That's enough for variables. When we come back from lunch, we're going to go into other concepts like if, then, else, control structures, and stuff like that. We got a little bit more to do today. A lot more to do, actually. Let's take lunch. Let me stop this video. People at home don't need to know about lunch.